Classful IP addressing was introduced to support different sized networks. Class A could support large networks, Class B could support medium-sized networks, and Class C could support small networks. Thus, classful IP addressing provided a simple design with a somewhat reasonable flexibility to support different sized networks. And since the classful IP addresses are associated with their default subnet mark, they themselves keep information regarding what part of them identify the network and what part of them identify the host within the network. Thus, routing seemed to be much easier. But as internet grew faster and the requirements kept on increasing, the depletion of IP addresses was found to be a major issue. The flexibility provided by classful IP addressing was found to be very less. Suppose one organization A needs to support 500 hosts and an organization B needs to support 600 hosts. A Class C network can support only to a maximum of 2 power 8 minus 2 hosts or 254 hosts. Thus, assume that ISP assigned two Class B networks to each of these organizations. Let them be 137.57.0.0 and 137.58.0.0. Now, each of these Class B network can actually support a maximum of 2 power 16 minus 2 hosts or 65,534 hosts. But organization A needs to support only 500 hosts and organization B needs to support only 600 hosts. Thus, in each case, a lot of IP addresses are wasted. And the reason for this wastage of IP addresses is the lack of flexibility. Here, we are not assigning the addresses according to the user requirements. We are just assigning a fixed block of IP addresses. A solution which was introduced to add flexibility to classful IP addressing was subnetting. Subnetting is actually dividing a large network into a number of smaller networks or subnetworks or subnets. A network with network address 137.57.0.0 is actually associated with a set of IP addresses from 137.57.0.0.0.1 and so on to 137.57.255.255. Thus, there are about 2 power 16 IP addresses or 65,536 IP addresses. Instead of assigning this entire set of IP addresses to organization A, let ISP divide this set of IP addresses into 64 blocks, where each block consisting of about 1000 IP addresses. Then let ISP assign the first two blocks to organization A and organization B respectively. Now all these remaining set of IP addresses and the entire set of IP addresses under 137.50.0.0 are saved. We can use all these IP addresses for assigning to other devices. Thus, each block can support about 1000 something IP addresses and organization A needs 500 IP addresses, organization B needs 600 host IP addresses. Thus, a very few IP addresses are wasted. Hence, subnetting adds flexibility to classful IP addressing and minimize the wastage of IP addresses. Now suppose one organization C needs to support around 60,000 hosts. Thus let ISP assign this Class B network 137.58.0.0 to organization C. Now, maintaining and managing such a large network is not easy for the network administrator. Dividing this large network into smaller networks or subnetworks or subnets can help to organize this network in an efficient way and can simplify the maintenance and management task of the network administrator. The subnetting in classful IP addressing can ease the administration tasks. Also, having the network divided into different subnets, we are able to control the flow of traffic through the network. Network congestion can be reduced and the overall network performance can be improved. Then, by dividing a large network into subnetworks, we can provide clear separations between them by setting rules to limit the traffic between them. Hence, improved network security can be achieved. But now the IP addresses are not associated with their default subnet mask. From just these IP addresses, we are not able to identify to which network it belongs to. Here, we need the help of some extra information called subnet mask. In classful IP addressing without subnetting, the IP address themselves keep information regarding what part of them identify the network and what part of them identify the host within the network. But while using subnetting, we are adding variable number of bits to the network identification portion, and hence we should make use of some extra information called subnet mask to identify to which network an IP address belongs to.